We were just a bunch of nerdy kids who ignored the haters. We took their ridicule and we built on it. And when some of us gave up, well, we built on that too. Built resilience, built on a mission to make things a little better every day until the users came. Then the haters were VCs who scoffed at our audacity. This just isn't the way things are done. But we kept building. Users turned into teams, turned into companies, running their entire businesses on our apps. Then the software giants came after us. We weren't proven, we weren't fully featured, our radical cloud model wasn't secure. But we built on. And today, as companies adopt the cloud to move faster, teams are finding themselves slowed down by each other's efforts. The skeptics are claiming we'll never develop innovation at scale. But now, DevOps have come to the cloud, ushering in a new era of transformation. Companies can release on demand across hundreds of environments, innovating faster with fewer conflicts and fewer disruptions. There will always be challenges. There will always be naysayers. And we'll build on.
My name is Giovanni Modica. I'm a senior technical architect. You can see my Twitter link and my LinkedIn link in there. So in case you want to know more about my background, so you can do that if you want. So the first thing that you might ask is lesson. So the call is the name of the talk is lessons learned from Salesforce Heroku implementation. So the first question you might ask is, well, lessons learned from what exactly? Okay, so this was a real project that we implemented last year for a very big customer here in Spain. So to give you some numbers, the project time was around 10 months with a team of 8 people, which I had the privilege to lead. It was a B2C implementation, person accounts, and with more than 10 million records for accounts. We had 3,500 users spread across multiple regions in Spain and Portugal. And in terms of data, we had more than 80 million records for both transactional and historical data. And it was a very complex system. I mean, we had a lot of integrations with legacy systems. It was a very fun and challenging project. But the most important thing is that it was a successful project. So the customer was happy. It's still happy. So that's what mattered the most. So this is what I wanted to talk about. This is not a talk about how to configure Salesforce Connect and Heroku Connect. I believe there are pretty good talks that mention how to do this. And it's actually very simple. What I will do is introduce a sample scenario that will allow me to show the things I want to talk in here. And in terms of lessons learned, I mean, we learn a lot of lessons, but we don't have time to go through them all. So I will focus on what I consider are the most critical things that you need to know before going into a Heroku implementation. And one of those things is the performance of the global search in Salesforce. And the other thing is the limits for both Salesforce Connect and Heroku Connect. And then what I will do is give you some tips, specifically how to use views as external objects, which I think is a pretty cool feature that if you know it already, it might save you a lot of time implementing business cases. And then we will have some time for Q&A. So, I mean, the main objective of the talk is for you to know what considerations are there before going into Heroku implementation. So, I mean, the objective is that if we're going to have a Heroku implementation, we don't want things to blow up in our face like the guys in the slide, right? Okay, so let's start with Salesforce Connect. So Salesforce Connect allows you to integrate external data from external data sources. And it does that by exposing that data as what is called an external object. So an external object is pretty much similar to a standard or custom object, but it has its own limitations. But in terms of functionality, it allows you to have layouts, see that object interlining, do global searches, and even access those external objects and external data from Apex. So it's in terms of productivity, it's a productivity boost because it brings that external data and it publishes at a first-class citizen in Salesforce. There are different ways to use Salesforce Connect, or at least you can use different data sources, but we will focus only on what it's on the screen. It's the OData data source and the Apex custom adapter. So I will explain the Apex custom adapter later. But on the Heroku Connect side, we have two parts. The first part is this bidirectional synchronization between the data that is in Salesforce. It could be either standard or custom objects, and the data that you're going to have on your Heroku Postgres database. So when you start with Heroku Connect, you're going to have a Postgres, which is a SQL database, and Heroku Connect will keep the data synchronized between those two platforms. The other part to Heroku Connect is the publication of that the data that you have in your Postgres database as an OData data source. And that's where Salesforce Connect comes in. I mean, you can have Salesforce Connect read that information, connect to the OData data source, and use the external objects, as I mentioned before. The good thing is that, I mean, once you publish your data as an OData data source, I mean, you can have other systems like MuleSoft or any other system that understand or speak OData and have access that information as well. Okay, so they are, Salesforce Connect, Heroku Connect, they are better together. So this is a little bit a simplified architecture of what we had in this project. Okay, of course, the real architecture was way more complex than this, but I didn't want to get it too complicated for this talk. So what we have is, on the Salesforce side, we have our account information, so our clients. And then we needed access to invoice information. I changed a little bit the business domain to simplify things. So we have invoice information, okay, and this invoice information does not reside in Salesforce, okay? It actually resides on different on-premise or cloud systems that manage all this billing information. So that information needed to be in Salesforce, so it didn't make sense to actually put that information in that data into Salesforce. Okay, and one of the reasons is storage and performance. Okay, so what we did is we introduced Heroku Connect, and as you can see in this, in the diagram, so what we did was configure Heroku Connect to synchronize or bring the data from Salesforce, in this case the account, to the Postgres database, and then for the invoice data, what we have is, so fortunately the customer already had a message bus, and what we did was publish a web dyno with a REST web service that will basically aggregate all the information coming from this legacy system and put that information into the local tables here in Postgres. And then with Heroku Connect, we enable OData. We publish these tables as external objects, and then we brought that to Salesforce. So to give you an idea how that works, what I did is I configure a little demo here. So you can see here I have all my accounts. And then I have here I'm going to change this. I'm going to put this below so it doesn't bother me. So this is the Postgres database. So this is the actual data that is being replicated from from Salesforce, so we have access to all the accounts here in Heroku, in Postgres. Another thing that you will see is that if I go to one of these accounts, so you will see that we have 3 invoices. So this invoice information is not stored in Salesforce, but it is rather stored in Heroku. So if I do a select here in my invoice table, so you can see I have my invoices in there. And what we did was, so I'm going to use Postman to simulate that message bus or the external system. What I'm going to do is create a new invoice with number 005. So this will go to that web dyno, access the REST service, and create this invoice in Heroku. Okay, so we got a 201. That's good. Now, let's see that we have our new invoice here in Heroku. And the good thing about this is that it is available into Salesforce. And if I just refresh my screen, that information is already available in my Salesforce. So that's one of the good things about the external objects. I mean, you don't have to wait for batch processes or any synchronization. So you have the data in real time available. And it's not, again, it's not stored in Salesforce, which was one of the premises. When you have to deal with 80 million records, this is very, very useful. Okay, so let's go back to slides. So, you know, when we started working with this project, you know, we knew some of the considerations, we knew some of the limitations that we were going to face with implementing Heroku, and of course some of the benefits of working with Heroku as well. But you know, as with every project, you run into some unforeseen considerations. So one of the things that impacted us was the global search. So one good thing about external object is that you can actually do a search on external objects. So in this case, I'm doing a search on invoices. Well, in our case, we found out that global search was not very performant, and the reason for that is that when you do when you do a global search on an external object, and that object is very big, then you're gonna get a performance issue. The reason is because, you know, Salesforce will use a filter query, and it will use the contains operator on all text fields. So as you can see here, I captured this with just a normal debug on the developer console. And you can see here that the query that I have highlighted, it uses a contains on customer ID and a contain on invoice number. So this is because in my table I only have 2 text fields, but imagine a table where you have 10 or 20 text fields, okay? So if you're gonna, when database receives this kind of query and looks that the operator is contained, it's gonna do a full table scan on the database. And that, of course, is not good. So this is what actually is going on. So when the users start typing the search, so that will send the text that you type. It will send it to the external object. The external object will send it to the OData layer with in this case the contains operator. Heroku Connect will get that OData query, transform it to SQL, and send it to Postgres. So Postgres takes that query, sees a lot of contains operators, sees a bunch of OR criteria, and it says the only way I can answer this is by doing a full table scan. So if the table is very large, you're going to get a performance issue. So we tried different alternatives. So the first thing that came to mind is that there is an option on the data source that will allow you to use free text search, and that will change the filter condition for a search condition. So when we enabled this, we found out that it wasn't working. I mean, the Postgres supports free text search. So my guess here is that the data layer on the Heroku Connect side didn't support free text search. Okay, so this didn't work for us. Another alternative was to turn off the search on the external data source, but and then ask the customer to do use the global search for the data that was in Salesforce, such as accounts, but then use a custom lining component for doing the search for external data. But that is not seamless, and in my personal opinion, it's kind of ugly. And so the final thing that we tried some other stuff, but what we came up with and worked for us was to create an Apex custom adapter. So if you remember the first diagram I showed, that's one of the data sources that is supported by Salesforce Connect, and so that basically is that you create your connection using Apex. Okay, so the good thing is that you have full control on how you want to bring the external data, so you can connect to any external web service if you want, and you have total control on how you do that. Bad thing is that you have to code it, so you need developers to do this. So what we did is we had our external data source, our Heroku external data source with our data, and we disabled the searches on this external data source. And then we created our custom Apex adapter, and we enabled search on that specific, on this one, on the external data source for the Apex adapter. And so basically what we did was the following. I mean, we didn't want to write all the implementation of the Apex adapter. So what we thought was, why don't we leverage what we already have, which is the external object? So this changed diagram a little bit. So now when the user started typing that global search, in the global search, the global search was sending that request to our custom Apex adapter. And in that case, since we had total control, we basically changed the query to use an equal operator and only on the field that are indexed on the database. So we will do the query against the external object. The reason we did that is that we didn't want to code, call web services or develop a web service layer on the Heroku side. So we leverage what we had with the external object. Once we do the query against the external object, it will follow the same path. So the external object will do the query against the data, but this time the filter, it will use the equal operator only on the fields that we selected as with the primary key. Heroku Connect will take that, transform it to SQL, send it to Postgres, and now Postgres will say, okay, now I can do an index scan on this table because they're using an equal operator, they're using a primary key field, and that will return the results very fast. The next thing that we had to do, so once the user was presented with the search results, when you click on one of those results, it will make the request against the Apex custom adapter. And here again, we'll leverage what we had about the external object. So what we did was to we override the view action on this external object, and basically what we did was create a lining component that will do a redirect to the actual external object. So with just 100 lines of code, we were able to solve our global search performance issue, leveraging Apex custom adapter and the external object that we already had. So that solved our global search problem, and other issues or considerations that we found in the project. Some of these we knew already. So mean, if you work with Salesforce, so this will not come to a surprise to you. So there are limits everywhere. And we have limits, of course, in the Salesforce Connect and Heroku Connect. So if you read the documentation, so the first thing you will notice is that if you're using a OData data source, you have this kind of limits. So this one in particular, it's we have 20,000 OData callouts per hour, okay, on these editions. And so you might ask, or you might think, 20,000 callouts, well, that's a lot, right? Well, let's see what that means. So an OData callout is made every time you access an external object. So if you access external object from a related list, if you view if you open a record, even if you use an external object on reports and dashboards, on the global search, like I did before, I mean, that will count as a callout. And you only have 20,000 per hour. So in our particular case, with 3,500 users, I mean, if you do a little bit of math, that means that every user will have an average of 6 callouts per hour. Okay, so that's very bad. I mean, you cannot tell the customer, well, your users, they can only open 6 records per hour. Okay, so that's a very big problem. The good news here is that if you read, it says higher limits are available on request. So what the solution here was to log a case with Salesforce to request an increase on the limit. And every time you log a case with Salesforce, you have to justify why you need that. So in our case, we did a study of the average number of callouts per hour that we needed based on the operations that will be performed by our users. And in our specific case, we requested to have the limit increased to 300,000 requests per hour. Okay, so that will increase the number of callouts, average callouts per user to 86. Okay. In our case, that was enough, but I mean, if you're going to implement a Heroku project, make sure that this number works for you. Okay, it might not be the case. It might be the case that your users will need a higher number of callouts per hour. So make sure that you know this before even considering Heroku. Okay, so we had our case solved by support. They increased the limit, but then we were still getting some errors. I mean, we got this before going into production. When we started doing some of the tests, and so we thought, well, what happened here? Isn't the limit increase? I mean, why am I still getting this kind of errors? Well, it turns out that this is not a Salesforce Connect error, but it is rather a Heroku Connect error. Okay. So you can start seeing the difference between the two. And so when you go to the documentation, so you will see that there are rate limits. And in this case, we had the same 20,000 requests per service per hour. Well, okay, so let's log a case with Heroku support and ask them to increase the limit. And like we did with Salesforce Connect. Okay, well, it turns out that in this case it wasn't that easy. So the solution here was to buy as many Heroku plans as needed. I mean, it wasn't as easy as incrementing the limit, but you had to actually put some money into it. So in our case, we needed 300,000 requests per hour, and you only had 20,000 requests per enterprise plan. So basically, you needed the customer needed to buy 15 enterprise plans. The good thing about this is that if you talk with your account manager, you will probably get a very good price for it. So in our case, the customer, they got a very good price and was reasonable, and I mean, it didn't pose any issues, so they went forward with it, and we were okay. So this solved our limit problem also on the Heroku Connect side. Okay, good. So so the next thing that we faced is an order limit, and in this case is this one right here. It says maximum new rows retrieved or created per hour. It's limited to 100,000. Okay, so this was a little bit of confusing. So we actually didn't know what this meant. So it turns out that this is related to how Salesforce Connect assigns Salesforce IDs to external records. Okay, and to explain that, let me show you this this example. So we have here our external data. Okay, so we have our primary key on the invoice table, and we can see that external data exposed on our related list. The thing is that when you access that data, that external data, Salesforce will, on the Salesforce Connect side, will assign a Salesforce ID. Okay, so there's an internal mapping table that will map the primary key on the external data with the Salesforce ID. Okay, the good thing is that this table doesn't change. Okay, so when you get another record like the one I inserted before on the demo, so when you get a new invoice, okay, and you access that invoice, Salesforce Connect will look at its internal mapping table and see if there is already a Salesforce ID assigned to that record, and if there isn't, it will create a new one. Okay. The thing is that this is limited to 100,000 per hour. Okay. So we asked Salesforce whether it was okay to increase this limit as they did with the Salesforce Connect thing. Turns out that this is a hard limit. Okay, it cannot be increased. So hard limit means that, I mean, there's no way, because it will put at risk the pod, the multi-tenancy of the pod. So this is something that it cannot be increased. So when we started thinking about this, in the particular case for this project, we thought, well, there isn't a case where the customer is going to create more than 100,000 records per hour. Okay, that is not the case. But the issue was with historical data. So to give you an idea, so imagine that you have an account, and that account has 50 invoices, and you have a service agent having to go through all these invoices because it's solving a problem with billing, and it has to review those invoices. So it starts opening each one of these invoices, and so that requires the creation of a new Salesforce ID every time the invoice is open. So if we had 3,500 users, that means that they could only open or create 28 of those records per hour. Okay, so I mean, there was a risk that this limit could pretty soon be reached in production. But the solution here was to create a batch process that will query all the historical data, and starting from the most recent record first, because I mean there was a higher probability of looking at the most recent records. So as I mentioned before, that mapping table doesn't change. I mean, it will keep the same ID for that primary rows. Actually, you can do a little test. I mean, you can create an invoice, okay, and look at the Salesforce ID for that invoice that is being assigned, and delete the invoice again in Heroku, and create that same record with that same primary key again. And if you query the ID, you would say that Salesforce will keep the same ID for that record. So that table doesn't change. So what we needed to do is to make sure that we had all those IDs created before going to production. Sorry. Sorry. So what we did was around that batch process, we started running it like 2 weeks before actually going into production after we did the data migration into Heroku. And it took some time, it took some days to have all the historical data with new IDs, but eventually all the IDs were created and we didn't run with any issue into production with this particular one. Okay, good. So enough about limits, although we will still have something later, but let's now switch gears and talk about some of the cool things that you can do with Heroku Connect, Salesforce Connect. And one of the things that was like a Swiss Army knife in our case was the use of views as external objects. So this allows us to solve different business cases, and I'm going to show you what I mean with this. So let me show you an example. So imagine one of the requests was for the IT department. They wanted to see a log, a dashboard of all the performance of all the integrations that they have. So in this case, it was something like this. So they can see like for each of the system, how many errors they got, how many what was the breakdown of the errors. So they could monitor the health of the system, right? So in this case, after a few minutes of going into production, we only have 6 records in this log table. So let's go back here to Postgres, and if I do select here, this is my table, the base table where all the record, all the logs were saved. So I only have 6 records there. But let's wait. Let's fast forward a few hours or a couple of days, and what I'm going to do is going to add 100,000 records to this table. Okay, so I inserted 100,000 records, and now I'll go to here to software. I'm going to refresh my dashboard. So as you can see, I mean, it's taking some time to refresh because it's reading all those records. So this is one negative thing. And the other thing is that you can only see 20,000 records. And this is because one of the limits on the OData, the Salesforce Connect side. So this was not good. I mean, you don't have the full picture. You only have a partial picture of what's going on. So the problem with this is that you don't actually need to access the 100,000 records. What you need is a summarized view of that information. So that's what we did. I mean, we went to Heroku and we created a view. So you can see here my view integration log stat, and we do our grouping. We do the aggregation on the actual view. So now if I just query this view, instead of 100,000 records, what I would see is we only have 36 records. Okay, so if you design, so what we did was to redesign our dashboards to actually use the view. So this is the same dashboard that you saw before, but it's using the view. So now if I refresh this, the first thing you notice is it's way much faster, okay, which is good. And the other thing is that we have all the records that we need. So this is a full picture of what's going on with my system. So the trick here was, I mean, how can we, so in order to do this, in order to show this nice dashboard, so we needed to access that view as an external object. And if you go to Heroku Connect, I mean, if you try, I mean, this is the Heroku Connect where you can select the external objects. So you will see, so this one here, right here is a view. Heroku Connect will not allow you to select it, okay? And the reason for this is that because Heroku Connect needs to identify a primary key column, okay? Because of the mapping table I mentioned before. So if no primary column table can be identified, Salesforce Heroku Connect will not allow you to select that object to publish it as external. So we all know that views don't have primary keys. I mean, however, the primary key is actually on the table, it's not on the view. So, but in this case right here, this is the actual view that I showed you before. We are allowed to select this view, and the trick is that all you need to do is to make sure that you have a column on your view called ID. Okay, if you put this column, so Heroku Connect will think that there is a primary key in the view and will allow you to select it. Okay, of course, if you're gonna do this, like in this case, make sure that this column is actually backed up with a field that is indexed. Otherwise, I mean, you will get some performance problems. So that's all we did, and let me go back here. So all we need is to have this one column with the name ID, and now you can expose views as external objects. Okay, so we use this trick to solve different problems. We did a use case with forecasting. And we even use this in some other scenarios. So here is a far-fetched one with Einstein Analytics. So the use case here was the customer wanted an analytics dashboard with account information, but they also wanted to include support information, like, for example, the total number of reported cases, how many of those cases were escalated, total cases by category, etc. Okay, so in Einstein Analytics, what you will do is, get the account info from Salesforce, get the case info from Salesforce, and then use SQL, which is the query language in Einstein Analytics, to aggregate the support information and then augment the account data. Okay, so in our case, what we did was take leverage that view trick that I just showed. So what we did is, since we had Heroku Connect, we had our account and case information synced to Postgres. Now we basically had all the information in Postgres. We created a view that will aggregate all that support information, and then in analytics, we take the account information from Salesforce, and then we take the support information from that view, and then we build our data set using that view instead. So it was simpler because I mean, we didn't have to do any SQL, and it was effective. Okay, so I'm not saying that you have to do things this way. I mean, this is just an alternative and another way of looking at or solving a problem. Okay. Okay, so I don't think I have too many minutes left. I don't know how yeah, I think I only have 2 minutes, but I just wanted to end up with some other things to consider when you have a Heroku implementation. So I already talked about the use of views as external objects. Another thing is that Heroku Connect is not only limited to external objects, okay, and data synchronization. I mean, you can make use of web dynos. Have your it's pretty simple to create a web service layer on top of that. I mean, in our case, we use Node.js. We created a service layer, a web service layer on top of the database, which allow us to receive incoming data from all those external systems. So it's pretty easy to do that, with Node.js, but you can use any other language supported by the Heroku platform. You can use Java, you can use Go. There are many things, but I think the most popular is Node.js. Another thing is that since we have all our data in Postgres, because because the external data is consolidated in Postgres. The Salesforce data is also in Postgres because of Heroku Connect. So it might make sense to move some of your batch processes from Salesforce to Heroku. Okay, because I mean, for some cases, Postgres is a SQL database, is optimized for doing set operations. So it makes more sense in some cases to actually do the batch processing in Heroku. So to give you an example, so imagine that you have those 10 million records, those 10 million accounts, and you needed to have like a year-to-date invoice information, like a year-to-date figure of how much has that specific account contributed to the business. So I mean, instead of going through the whole invoices and all the 10 million account records and calculating where it will be that account that amount, you can do that on Heroku, okay, using set operations, using SQL query, and then update Salesforce with that information. So it will be much faster, and I think it's going to be better. So you might consider that in some cases. And the last thing I want to mention is archiving. So it's pretty easy to do archiving with Heroku, okay? With Heroku Connect, it's just a matter of, so since you have your account information, well, not account, but any other object like cases, you have that replicated to Heroku, you can just do an archiving by just removing records and moving those to staging or archiving table in Postgres. Okay, so the bidirectional synchronization will take care of synchronizing that. Of course, you have to resolve some referential integrity, but it's actually pretty easy to do that with Heroku. Okay, so to summarize lessons that I learned, again, a lot of lessons, a very challenging project. If I had to summarize those, make sure that you do a study before implementing Heroku. Understand the limits on both sides, okay? Do a study of the data volumes and the number of operations, types of operations that your users will require. Be careful of platform limits, know them, understand them, and know how to work around them. So hopefully with this talk, I gave you a little bit of insight on that. The other thing is, do not underestimate working with very large data sets or data, very large data. Consider performance. So every time I go into a project, the first question I ask is, how many records are we dealing with here? And if we're talking about millions, I get a little bit nervous. I mean, it's challenging. Make sure you bring all these considerations at the beginning of the project. I mean, nobody wants surprises in the middle of a project. So hopefully you have the tools and to do this at the beginning. And the last thing is, take advantage of Heroku. It's not only limited to external objects. So think outside the box and take advantage of what it has to offer. Okay, so there are some resources here. I don't know if you're going to have access to the slides. I can publish them, but there are also some links that I put in other slides when I was referring to limits. And this is it. So thank you very much for your attention. I hope that this has been useful to you.
So to start with the Q&A, the one question is, any implications if we use SAQL over the Heroku views in Einstein Analytics?
Any implications? Well, it might be that, the processing time of, so, the data set, you need to process it on a scheduled basis. So maybe some of the implications is to make sure that it doesn't time out on the Heroku, on the Postgres side. One thing that we did was to increase the timeout on the Postgres database to make sure that we didn't have any timeouts. So other than that, you know, it might solve some of the business cases, but again, I'm not saying that that is the way that you should go. I'm not an Einstein analytics expert, but I know that that works and that helped us solve some of the issues. I'm sorry, some of the business cases.
Okay, thank you. One question is from Jacob, and he asked if we have private account sharing settings, could we make external invoices visible only to people with access to related accounts? And then the detail is they are going to be able to find any invoices in global search right anyway. So
yeah, well, external objects, I mean, you cannot set sharing visibility on external objects. So that is an issue. So you may want to turn off searches on external objects. You know, usually in this case, in this specific example, I mean, if you open if you have access to the account, then you will have access to the external object. But in the case of the global search, one way to solve that is using the custom Apex adapter, as I mentioned before, where you have control over what is being searched. So you might actually use that to limit the records that are shown. But other than that, I mean, there is no way to set in the private an external object to private, I believe.
okay. Other question is what is the need of Lightning component to redirect? So
yeah. Okay, so when you click on the record, so maybe you can go back to that particular. So when you click on the record, this will forward the request to the custom adapter. Okay, and so you will have. So imagine that your table, your external object, has 100 fields. Okay, so you will have to provide that data, those 100 fields to Salesforce in order to show a page layout for that object. So we didn't want to do that, and also that means that they had to maintain like two layouts, one for the external object and one for the external object created by the Apex custom adapter. So we didn't want to do that. We only wanted to solve the search performance. So what we did is, instead of implementing all the fields, okay, all the functionality of the custom adapter, we will leverage the external object whenever possible. So we only manage here a couple of fields, okay, and then when the user click on this, I mean, it will open a Lightning component, and we will forward that using that primary key. We will forward that request to the external object. So in this case, the page layout for that external object with all the fields and all the customizations that the admin did on the page layout will show instead of our custom adapter object. Okay.
Another question is about global search, and the question is that how do you invoke the custom adapter to only restrict itself to a big custom object data or big object data?
On the custom adapter, I'm not sure I understand the question very well, but on the custom adapter, I mean, you can see here that says get capabilities, and then you have to implement an interface where you do the search and you have a query. Okay, so you can here on the get capabilities, you specify what objects you are supporting, okay, and what operations you are supporting. So in our case, we only supported the specific objects that needed global search. Okay, so if Heroku or Heroku data source had like 20 external objects, but our custom adapter only supported 2 of them, because those 2 objects were the only one that required to the global search. Okay, so we didn't have to implement global search on all the external objects. Okay, only the two that matter to us, and we specified that in the definition of the custom adapter.
Okay, so another related question on global searches: does this custom adapter search works when you are searching for internal Salesforce data as well?
Yes, yes. I mean, you can do. I mean, you have full power here. You can do. Actually, that's a very good question, because this will allow you to group or provide different views of the data that is in Salesforce. So you can see it like a view on top of the Salesforce data. You know, the bad thing about this solution is that Salesforce Connect is licensed by data source. So if you want to do that, you will require a new license for this. Again, the good news is that if you're only using it to solve a global search issue, then you're probably going to get a good price for just that, with some limitations, contractual limitations. But and keep in mind that this is not free. I mean, it's licensed by data source. So if you want to do that, you're going to need a new one.
So thanks a lot to all the attendees, and thanks a lot, Giovanni. That's all we have, and you have coordinates of Giovanni. In case you have question, reach out to him on Twitter or LinkedIn. Thank you, everyone.
Yeah. Thank you, everyone. Have a good day.